Hi, I'm Don from Math Eternal, and this is how to find the gradient of a line through 2 points. The gradient of a linear equation is the measure of how steep it is, and it is important for finding out how the line looks on a graph. The way to find the gradient is by using rise over run, where rise is how vertically far the 2 points are, and the run is how horizontally far the 2 points are from each other. We denote gradient as m, the rise as the difference between the y-coordinates of the 2 points y1 and y2, and the run as the difference between the x-coordinates of the 2 points x1 and x2. So, if you have two coordinates, A, where the x-coordinate is x1 and the y-coordinate is y1, and B, where the x-coordinate is x2 and the y-coordinate is y2, the gradient of the line through those 2 points will just be m equals to y2 minus y1 over x2 minus x1. As you can see, the line will be steeper when the gradient m is at a greater value. This is because the ratio of rise over run will be greater as visualized through this graph. We can see that if we increase the gradient, the rise will be much greater than the run, and if we decrease it, the rise will be much shorter than the run. With this concept in mind, the line will be tilted downwards when the gradient is negative. Here, while the run stays positive, the second point essentially falls below the first point, hence the rise becoming negative. We have two special cases that I want to talk about. If the difference of the y-coordinates of the 2 points is 0, in other words, when the rise is 0, then the gradient of the line passing through those points must also be 0. So for any horizontal line, the gradient is 0. When the difference of the x-coordinates of the 2 points is 0, in other words, when the run is 0, then the gradient of the line passing through the 2 points is undefined, or infinite. Here, we will see that the line passing through these points is a vertical line. Note that it doesn't really matter which coordinate you place first for the rise and the run, which means the gradient can be m equals to y1 minus y2 over x1 minus x2. By simple arithmetic, we can see that this is the same as the previous formula for m. However, you must not mix the x and y coordinates around so that m equals to y2 minus y1 over x1 minus x2, or m equals to y1 minus y2 over x2 minus x1. That is not allowed. Now that we have learned the fundamentals about gradients, let's move on to some questions. Question 1. Find the gradient of the line through m23 and e47. Here, we use the gradient formula that we just learnt, so m equals to rise over run. So rise is the difference of the y coordinates of e and m, so that's going to be 7 minus 3. And then the run is going to be the difference of the x coordinates of e and m, so that is going to be 4 minus 2. So that equals to 4 over 2. Simplify that, and that is equal to 2. And we can see that the line through M and E looks like this. And it does make sense because the line is fairly steep and it stays consistent with the fact that the gradient equals to 2. Let's move on to the next question. Question 2. Find the gradient of the line through T minus 1 minus 8 and E minus 8 13. So this is the exact same thing where m equals to rise over run. You don't have to write this out, but I'm just writing it down so you guys can remember what the gradient formula looks like. So here we have 13 minus 8 over minus 8 minus 1. And of course, double negative becomes positive, so that's going to be 13 plus 8 and then minus 8 plus 1. So this becomes 21 over minus 7, which is going to be minus 3. And this does make sense as well because in this graph here, the gradient is negative and it's fairly steep, and this stays consistent with the fact that the gradient equals to minus 3. Question 3. Given that the gradient of r minus 9, 2 and n minus 7 Given that the gradient of r minus 9, 2 and n minus 7p is 5, find p. So here, the question doesn't ask you to find the gradient directly, but it is sort of an application type question where we use the knowledge of gradients to find the missing value p. So let's get started. So we have m equals to y2 minus y1, and then x2 minus x1. So of course that is the rise over run. So since m is actually 5, and then that equals to p minus 2, and then we have minus 7 minus 9, so that's going to be plus 9. And here we have 5 equals to p minus 2 over minus 2. And here we have 5 equals to p minus 2 over 2. And then multiply both sides by 2, so we get 10 equals to p minus 2. And of course, p should equal to 12. Here is the line with gradient 5, and it indeed passes through R and N, where p is 12, just like how we found in this question. Let's move on to our challenge question. So given that the gradient of A minus 2, 5q, and L minus q minus 3 is minus 8, find q. So I want you guys to try this on your own, and the answer will be given in a few seconds. But make sure to pause the video and try it yourself. Here are the solutions to the challenge question. So we have m equals to y2 minus y1 over x2 minus x1. So gradient is given as minus 8. y2 is going to be minus 3, and then y1 is going to be 5q, so that's minus 5q. And then x2 is minus q, and then x1 is minus 2, so that's going to be plus 2. Then we have minus 8, and then we have minus q plus 2, and then minus 3 minus 5q. Let's go down to the bottom. And here we are going to have 8q minus 16 minus 3 minus 5q. And then let's move 5q to the other side and 16 to the other side as well. So 5q plus 5q, and it's minus 3 plus 16. So now we have 13q equals to 13, and then q is just going to be 1. Here we can see that the gradient of this line is minus 8, and it does make sense because it's very steep and it's a negative value, so it should be sloping downwards. And since we found that q equals to 1, the first point should be minus 2, 5, and then the other point should be minus 1, minus 3. There you go. All it takes to find the gradient of a line through 2 points is to remember rise over run. In a future video, we will learn how to find the x and y intercepts of a linear equation before we find its equation in the form of y equals to mx plus c. Thanks for watching.